Hola, hola gente, bienvenidos. Es un placer para mí, Gerardo López Falcón, estar en esta noche con todos ustedes. Gracias por estar con nosotros. El día de hoy tenemos la última actividad de este año, tanto en las comunidades de GDG Pura Vida, Google Developer Group en Costa Rica y también la comunidad de Docker Costa Rica. Juntos hoy estamos organizando esta actividad y contentos, entusiasmados de poder traer algo diferente y cerrar este año, o por lo menos las actividades de este año, con temas realmente relevantes. Antes de presentarles al invitado especial de esta noche, quiero compartirles un poco nuestras redes sociales para que ustedes nos puedan seguir, puedan compartir un poco sobre todo lo que estamos haciendo y lo que estamos interactuando en diferentes formas. Entonces, acá les comparto la red social de Docker Costa Rica. Acá pueden ver las diferentes actividades que estamos haciendo. Nos pueden encontrar como Dockeritico y ahí estamos sin ningún problema para poder interactuar con cada uno de ustedes. Al mismo tiempo, los invito a que se unan a la comunidad de Docker Costa Rica también. Esas las pueden encontrar más allá de Facebook, nos pueden encontrar en events.docker.com, Docker Costa Rica. Ahí nos pueden encontrar también para poder ver toda la información de las actividades que organizamos y todos los demás tipos de eventos que estamos participando. Y por último, y no menos importante, tenemos también a la comunidad GDG Pura Vida, el Google Developer Group acá en Costa Rica, en el cual organizamos diferentes tipos de actividades, o diferentes tipos de grupos de estudio, charlas, entre otras cosas. Así que si usted no pertenece a ninguna de estas comunidades y es la primera vez que está con nosotros acá, pues bienvenido y bienvenida, y los invito a que nos sigan también por ahí. De nuevo, mi nombre es Gerardo López Falcón y participo en diferentes actividades. Soy un Google Developer Expert en Cloud Technologies y regularmente me han visto o hemos participado en diferentes actividades. Así que para mí es un placer ser el host de esta actividad y gustoso de nuevo de que usted esté junto con nosotros en esta noche. Así que, sin más preámbulo, voy a presentarles al invitado especial. Voy a moverme a inglés porque nuestro invitado, pues, él es de Estados Unidos, él es Mark, así que permítanme introducirlos a ustedes de forma apropiada. Ok, voy a compartir. Ok, hay un dedazo por ahí. Sorry. So, okay, Mark, are you there?
I am here. How are you doing?
Yeah, nice. It is the nerve right now, but we're happy that having you in this activity. So, guys, let me introduce our special guest. He is Mark Mandel. He's a developer advocate for Google Cloud for Games and founder of the open source multiplayer dedicated game server scaling project Agones. So maybe Mark can tell us more about that in the new minutes. So Mark, he is hailing from Australia. Interesting. Mark built his career developing backend system for over 20 years and authoring and contributing to several widely adopted open source projects. In addition, when he is not building infrastructure, busy man, in the cloud for game, he is constantly looking for new interesting things that maybe he can do with Docker containers, super fan from Docker. And yeah, playing with his dog and reading too much from fantasy literature. So Mark, again, for us, it's a big pleasure having you here in this community. So thank you again. I'm totally sure that we will learn a lot about the different stuff that you will bring this night. Thank you so much.
No, my pleasure. Thank you so much for having me. This is going to be fun. I'll share my screen in just a moment. But yeah, throughout the talk, if you want to put comments in the comment box, I'd love to see them. Great to, I mean, I'm virtual environment now, but it's always great to have that interactivity. So definitely appreciate it. Where are we? Let me pull this up so you can see pretty slides and stuff. Cool. So yes, thank you so much for the wonderful introduction. I really appreciate that as well. As we said, my name is Mark Mandel. I work with Google Cloud. I work on a fun project called Agones. which is, we won't get stuck into that, but that is an extension of Kubernetes for running multiplayer game servers. But why don't we can sort of talk about what does that mean and what does that do? But what I'd love to actually do here, given the opportunity, and if I actually click the right thing, I'd love to know about sort of all of you and the community you're in and the sort of stuff all of you do. I'm going to make the assumption that most of you probably don't do infrastructure for games, which is totally fine. But please let me know if you do, or if you don't. That's totally fine. I'm willing to bet what's probably more interesting for y'all is going to be more about like how we're using Docker and Kubernetes to do this kind of multiplayer work. How we extended Kubernetes to make this sort of stuff happen, and sort of some of the approaches we took and that kind of stuff, and sort of explain some of the background more about multiplayer games and why this was necessarily fit together. I see like a thumbs up or something in chat, like, yeah, that sounds pretty good, and that's in line with what we're looking for. That would be awesome to get that back. Also, would definitely also love to hear from you all about like how experienced some of you are with like Docker or Kubernetes. We can sort of take these back to first principles as well, if that sort of fits what it is you're doing. That's all totally cool. We're actually going to sort of dig into a few different pieces here and why some of this stuff works really well for the environment we're talking about here, which is gaming. Give it a second, see if anyone responds. I'm not seeing anything, which is fine. We can go ahead, and I'll just assume that what I said was correct. Nothing. All right, let's just keep moving on, but that's fine. We'll have lots of fun regardless. All right. So cool. So Daniel's giving me 2 thumbs up in chat. Love it. All right, fantastic. That sounds really good. And I'm actually gonna put my phone on silent because it's buzzing me right now. That was a bad move on my part. All right, excellent. So let's talk a little about multiplayer games just in general, because that means like a lot of very different things to a lot of very different people, and there's a lot of different types of multiplayer games. So the sort of games I want to talk about are your very fast-paced online multiplayer, like competitive action games primarily, where there's a lot of interaction between all the people who are playing this game together. So the demo I'm going to use today is a free first-person shooter game called Synodic, if anyone's played it. If anyone played like Unreal Tournament back in the day, or Overwatch, or things like that, it's really much in that sort of ilk of games, right? And it has a lot of, players running around in a map. We're all trying to like usually do some kind of death match, something like that, where you're trying to shoot each other. And there's just a high level of interaction between the players that are playing those games. And so we're going to talk very specifically about those types of multiplayer games that many of you may already be familiar with if you've played things like Overwatch or Fortnight, those sorts of, very fast-paced games. Rocket League is another great example, etc. And sort of talk about some of the patterns for how games go about doing that sort of synchronizing of state between all the players that are playing, and how Kubernetes and containers kind of help us with that. So let me take a swig of water. To give you some background, one very common pattern for doing this kind of work, and there are a few, but this is very prevalent in sort of very large game studios, is what we commonly refer to as a dedicated game server. And a dedicated game server is essentially a software process that runs somewhere on the internet that has a full simulation of everything that's happening inside your game. So think of it as like it knows where every player is running around, every person's doing a thing, every rocket that's like spinning up, every car that's driving, and the interactions that happen with them. And what happens is all the players connect to that dedicated game server and send it the information of what they are doing inside that game. So it might be the person on the left is running, to the left or something like that. And it tells the dedicated game server. The game server will do the full simulation of all the physics, everything that's happening, all that kind of stuff. And it'll send that information back out to the rest of the people who are playing the game and be like, this is what's going on. And there's a lot of really good reasons for that. Some of which are around actually cheating. So having a dedicated game server in a specific spot is really handy, because I like to use this model, which is like, the client can be like, hey, I'm kind of asking to go forward, even though that's what I'm doing. And it's up to the dedicated game server to be like, yeah, that seems like a reasonable operation. But if, the client is more like, I'm actually should be just like 200 meters that way, even though that's not something that's legal in this game at all. The dedicated game server can be like, no, you shouldn't do that. That's bad. By the same token, the other nice thing about dedicated game servers is that you have a lot of control over where you put them around the world. So as we're looking at sort of these very fast-paced games, usually latency is like a really big thing, right? You probably want about 50 milliseconds latency between you who's playing the game and the person and the dedicated game server I'm connecting to. So I'm going to need them all around the world so that I can make that connection in that time. But because I can put them anywhere around the world, I can measure that latency, and then I know what kind of experience my players are going to have when they connect to those games. It gives me a lot of control over the experience that those players are going to have, which is also super nice. So dedicated game servers are great. I really like them. And we're going to talk about them a lot today, funnily enough. So before we continue on there, and also I'll just reiterate as well, if you have questions about anything I'm saying, please throw them in chat. Definitely we'll get to them as well, especially as we go through, because we're going to keep building on all this stuff as we go. So let's look at, say, a traditional architecture for a common multiplayer game of some kind, right? So say, for example, here, you might have two players who want to play a game. What commonly happens is those two players will communicate to like what's often referred to as a matchmaker. And they'll be like, hey, we want to play a game. And the matchmaker might look at them and maybe a whole bunch of other players and be like, let's look at their skill level, maybe look at their social graph, other interesting things about them, and decide, okay, these two players should play together. They're going to have a good game. And they're like, all right, cool. And then the next job of the matchmaker is to say, all right, cool. We've got these players who should play a game together. We need to get a dedicated game server for them to play one. So they'll talk to some kind of server manager. And this server manager's job is to look at a whole lot of machines, strangely enough, distributed around the world, find the right process on it, or maybe start a new one, look at memory and CPU metrics, things like that, work out where in the world is the best place to put this dedicated game server, and coordinate its startup time and processing and get it all up and running. If this is starting to sound very familiar to you, you may see where we're going to head with this. Right? Okay, so they're going to get this dedicated game server running on this huge set of machines spread around the world, get that information, send that back up all the way up to those players that are those game clients that we see over on the left there, and give them, usually actually you get just the IP import of that game server. And so that those players can make direct connections all the way to that dedicated game server. So usually there's no load balancers. They're usually sending UDP traffic for a variety of reasons as well. We don't want any extra latency. So they're usually going to connect directly to that game server because they're all playing on that same in-memory simulation that's happening on a dedicated game server. And this just kind of happens over and over again. And so the interesting part of this, at least I think the interesting part is anyway, is if we look at that whole machine cluster thing, you may be saying to yourself, wait a minute, I know something that manages big clusters with lots of VMs and runs processes on them. I have some thoughts on what that might be. Maybe we do some Kubernetes type stuff, or maybe some container stuff there. That could be kind of cool. Because usually, to be honest, a lot of the time, this whole part of it is usually bespoke. A lot of big game companies write this themselves. And it's just a lot of infrastructure work that they shouldn't need to do. And I see there's a greetings there from Mexico City. Greetings to you too, Aaron. Nice to see you as well. Okay, so fantastic. All right, so we've set the stage. Yeah, we've got this whole game server thing. And I don't know about you, but I get a little upset when I see people constantly reinventing the wheel. So myself got together with some other big game studios, and we built this open source project called Agones, which is basically a batteries included dedicated game server hosting and scaling project. Basically, in the same way as you would orchestrate web servers on top of Kubernetes, we tell Kubernetes how to orchestrate game servers. And we'll take a little bit into like why they are so special and why they need very specific tooling to enable them to do that on top of Kubernetes as well. So we'll get stuck into that as well. So yeah, we came together for this. It's been going for 3 years now. Maybe 4 even? No, it can't be that far. It must be 3. That sounds about right. And it's been going really, really well. We've got a great number of adopters across a variety of platforms. We have a managed product as well on Google Cloud, and I'll touch on that very little bit later on. But yeah, and it's all open source, and we have lots of people who contribute from a wide number of game studios now. It's been going super well. I think we're at 3,500 stars on GitHub, something like that. So I think we're very close to 100 contributors as well. Okay, so let's get stuck in. Why do containers and Kubernetes work so well here for what it is we do? So, okay, so first things first, right? Like maybe you've got a dedicated game server. It's a software process just like any other. Usually the maybe one limiting thing there, or the one interesting thing about it, is quite often they tend to be quite large. The game server, we're going to look at it later. The Docker image is like 1.5 gigs, which is not unusual at all. But we can, much like any other process, we can throw them inside a Docker container, right? This is actually super cool. Dedicated game servers, sometimes have like dedicated processes. Maybe they have their own a whole bunch of data assets and stuff like that. But we can wrap that up inside a Docker container. And I think this is probably something you're all pretty familiar with at this point. From what I understand. But just in case you're not, I just want to show you, right? There's no magic here in any way, shape, or form. So here is a cut down sample, I will say, of running the Sonotic dedicated game server inside a Docker file. We're running Debian. Cool. Nothing special there. We download Sonotic. We unzip it. Sonotic basically has you copy some files around, so it sets itself up as a dedicated game server, and then we run it. Right? There's nothing too magical in there. It's just a container, and it gives us a lot of flexibility too, which I really like about it. Right? Like standard standard Docker container stuff. If we want to put extra binaries in there, if you want to put anything extra that you want that's important for your dedicated game server, you can all put it in there. It's just a lovely piece of sort of this resource block that can be run in almost anywhere. And yeah, the standard sort of flow applies, right? We write a Docker file, we can host that up on a registry, we give it a tag and a version number, and we get all those great Docker benefits. Like we know what image it is we're running, and we know like what tag it is, and we know that it's secure, and we know that only certain people can download it if they have the right things, that kind of stuff as well. So all the usual stuff, which is great. I will say one thing though, because of some of the slight differences of how game servers run, and also some utilities we want to have, we do have an integrated SDK with Agones. It's actually gRPC based if anyone's interested, and also provides REST interfaces, but we have native clients in Unreal and Unity and C++ and Go and Rust and Node and C#. And this does a couple of interesting things, I think, that are slightly different than what some people would probably be used to from running web servers. So one of the big things this does is, so talking about before, game servers can be really big. Sometimes they can also be really slow to start up. So a game server that takes 30 seconds to start up, not unreasonable. So because we're also not putting things behind load balancers, so we don't have the same readiness check sort of availability type stuff that traditional Kubernetes type things have, we actually have a thing that's built into the SDK that actually marks whether or not a game server is ready. So when it starts up, it can mark itself as ready. It's like, hey, I might have loaded like a whole bunch of map files or asset information or just models for what's happening inside my game. And now I'm ready to be used. We'll dig more into that as well. And then we also pull in a whole bunch of other interesting stuff, like we do our health tracking through it rather than using the health HTTP point. We just hide that all away in a nice way because we do some custom stuff there too. We provide abilities for like the game server to know like what its configuration is, be able to expose some values, other such good stuff in there too. It's super handy type stuff. So give you a quick example. This is some C++ code, and please don't critique my C++ code because it's terrible. I'm sure this is fine. So here you might see like a process that starts up. We can create an instance of the SDK. It's going to do a nice blocking connection. Just wait for the process that actually runs alongside it. So we'll see that in a minute, where we run this sidecar process, if you're familiar with the term, basically alongside the game server at the same time. It's going to connect to it on localhost, and you can see that it connects. Once it's connected, we might do some other work, but then we'll be like, cool, we're ready. Just letting you know. You can now use me for a game, and we'll look at that in a minute. So that's kind of the flow usually. And then game servers can also shut themselves down, all this kind of stuff, because usually you have all this very game-specific logic in this big game server kind of monolith. And so they are very aware of everything that's happening inside their game and whether they should stay up or go down or that kind of fun stuff too. So I'll give you a little demo, actually. This will be a bit fun. So we were talking a little bit before about how there's a sidecar process. And this is one of the things that we do inside Agones that's actually really useful. And one of the reasons why it's really useful is it makes it really easy for us to create local tooling that you can use at development time as well. So here we go, SDK server. So what I'm actually going to do is run the SDK server, which you can run in a sidecar, but it has a local mode. So I'm just going to run that. And really all the local mode does is just spit out log messages about stuff that's going on inside the system so that when you're developing locally, you can see everything that's going on and that your local development, you can do like fast iterations, but you can see everything's happening as the way it's meant to. So if I run the Synodic example, I'm just going to run it on the same network. We're actually just going to see that that'll spin up. And we've got a bunch of assets inside there. But it is going to, here we go. It is going to mark itself as ready here, right? So this actually gives you a really good example. You'll see like Synodic spins up. It took a few seconds. Actually, it's pretty quick. But there's like, it's pulling in all these variable files and like all these map files. And then sort of, here you go. There's opening all the maps, all this kind of stuff. And it takes a little bit for it to get started. But here we can see with our local SDK, we got the ready request. Here you can see health pings going by as well. So we can actually do this kind of stuff locally. And again, like we're just running Docker containers, which is pretty awesome because they're just this nice unit of being able to process stuff without having to worry about what's inside it. And this could be any kind of Docker container, from a Debian-based one to Alpine to whatever, and it could be running anything. But as long as it has that SDK built in and it sends the information to the appropriate place, then we're pretty much good to go, which is pretty awesome. Okay, let's turn that off. I prove to you that Docker is working the way it's supposed to, which is good. Okay. Moving on up. Okay, running one game server, cool. But what we actually want to do is run lots of game servers. Yeah. The classic problem of always having a single Docker file is kind of handy, but when you want to run at scale, you want to run lots. And what we want to do is basically also have like a huge set of these warm game servers, because they take a while to spin up, sitting there being ready, so that then we can do stuff with them, which we'll look at in a minute. Now, unsurprisingly, this is how we end up here. So Kubernetes, awesome. I'm going to assume you're probably familiar with it to at least, what it is. Right? I think we all probably have a pretty good idea, right? I like to just look at Kubernetes very much as just, it's a platform for telling a whole bunch of machines, hey, I'd like you to run this software, please. I think that's the way I look at Kubernetes, right? You're just like, Kubernetes, do this for me, please. That'd be cool. I really appreciate it. And Kubernetes is like, I will go do the thing. Thank you very much. And I think that's great. I really love that about it. And what's great about it as well is it's extensible. And which is just really cool. It's extensible. What we use, we'll sort of see it in a minute. You have these things called custom resource definitions. So if you've used Kubernetes, right, services, pods, you probably know deployments, things like that. You have these sort of nouns, these like objects there that you can do stuff with. By installing something into Kubernetes and installing Agones, you can get these new nouns. You can install these CRDs, these custom resource definitions, and some software to look at them that can tell it new stuff about what's happening inside your system. So what we do is when we install Agones, we tell it things. We have this thing called game servers. We'll look at a little bit something called fleets and some other things. We extend the native Kubernetes, and so we can take advantage of all that wonderful open source stuff and all the wonderful foundation that Kubernetes gives us for running processes over lots and lots of machines, exactly what we saw in the beginning. And we can do some really cool stuff with it. So I'll show you a few things. Actually, yeah, let's go. We'll go this way. I do want to talk about a little bit, and some people might be sitting here be like, but can't I just do this with standard Kubernetes? And I want to answer that question. But we'll dig a little bit further down into that as we go through here, because I want to explain a few things that are super important. So first things first, this is just if I want to run a single game server. When I install Agones, I get this kind game server. It now understands that I know what a game server is. I can do a kubectl get game server. What's actually also really cool, I don't know if necessarily everyone knows this, but when you install extensions into Kubernetes, not only does it make it so that like kubectl understands like new nouns, it also extends the Kubernetes API itself. So suddenly you actually have a whole bunch of new API endpoints, which is also really cool. So everything you can see we're doing here through YAML, or we'll see some stuff through kubectl, you can also do through your own programs that run on your clusters, which is super awesome and is exactly how all the controllers, or basically the pieces of software that react to these custom resource definitions, and that we'll see in a minute, that's how it all works, which is really cool. So what was I saying? Yeah, so here we can define a game server now. Now we've installed Agones. We'll actually do that in a minute. We can give it a name. We're going to call it Sonotic after the game server. Now, you remember previously I mentioned that game servers usually take direct connections. So we're not using services here at all. By default, Kubernetes doesn't give you a really good way of doing dynamic port allocation. So basically, like, pick me a port that no one else is using, please, and let me know what it is. You can get that functionality. We use a thing called host ports to do that. But we manage that layer for you, being able to be like, okay, the port that's running on the container for my game server, that's 2600 or 26,000 here. But you're going to give me back a random allocated port somewhere on this node that's free and available. And that's something that Agones gives you out of the box, because we're doing these direct connections. From there, we actually just specify the pod. It's basically the pod here. That template spec is a pod spec, if you're familiar with that, right? So I can do everything inside a pod. Here, I'm just defining what my game server image is. And here it's Sonotic. If I wanted to do volume mounts or add other containers or anything like that, I could totally do that as well. It's all available. I can extend that as I see fit. And I've definitely seen some big versions of this as well. So I'm going to show you how that works. Let's come back over here. So okay, pause. I will show you that we will start with nothing. Let's go with that. Okay, so let's install Agones first, and let's see if I get this right off the top of my head. This will be fun. Where are we? Install. Oh my god. Namespace. System. Agones. I feel like I might be forgetting something, but no, that looks about right. It's always fun typing stuff in front of a live studio audience. Okay, that's looking pretty good. So to install Agones, I can do it through a YAML file. There's also a Helm package as well. I prefer Helm personally, but that's just me. I find it easier for installing and uninstalling stuff. So that'll take a second. As we wait for just a minute. There it goes. Okay, excellent. All right, so that's really all I needed to do to install Agones. If we have a look at Agones system, right, we'll see there's a bunch of stuff in here. There's the Agones controller. That's the thing that actually responds to the custom resource definition changing and does stuff. We've got some other utilities in here for latency measurement and some other third party, but like some external services stuff. Let's not worry about that for now. Not that important. But we have all the bits and pieces we have in here. We have all the bits we need so that we can see things be up and running. So let's where are we? Create. Yes. Examples. Sonotic game server.yaml. So we're just gonna, like, this is, again, you see this, right? Standard kubectl commands, nothing special here. I'm just installing that game server before, but now we can do this, get game servers, which we couldn't before, which is kind of awesome, right? So this extension also enables us to specify what the output here is as well. So we have a lot of control over the experience that the user has when we do these kinds of extensions. which is kind of awesome. So what we do is we specify if it's ready or not, and here it's up and ready, so that's awesome. The IP and the port that it has, or like usually the first port actually, and then some other information like what node it's on, how old it is, that kind of stuff. We can even describe this if you want. Game server. I see. I even get code completion. Like the extension mechanisms on Kubernetes is super powerful and very handy. So we can do a full describe as well, right? So you can start to see where are we? I'm scrolling too fast. You can see like the kind is game server. It's looking very much like what we saw before. Here's some health checking stuff we didn't talk about. We can even get a series of events of what's happening inside the system again, very much like anything else inside Kubernetes. Okay, so that's cool. But, as we said before, there's only one of them. That's not very exciting. So let's delete that game server. I'm just going to do GS because we'll fry that one. GS is the shorthand for game server. And then we'll come back over to our slides and we'll dig in a little bit more. So just to sort of recap as well and give a bit more perspective. So now where we had the players talking to a matchmaker, that all stays the same. But that matchmaker can now talk to the Kubernetes API. We actually have some services if he wants to talk to things from outside of the Kubernetes API. We'll talk about that in a minute. But the matchmaker can now talk to the Kubernetes API, which can talk to a Agones system and get a dedicated game server that players can play on. Right. So suddenly there's a lot less bespoke stuff that needs to be built to handle this very custom workload. So if you happen to have other custom workloads or maybe like very opinionated application development practices that you have inside the company you work for or you want to build, you can start leveraging just so much of the tooling that comes from inside Kubernetes to do that, which is really amazing. Okay, let's take this one step further because I want to talk a little bit about game server lifecycle and how we manage it a little differently from how traditional, like say, web servers or even databases work necessarily. So I said before, what we need is a big group of game servers that are ready to go, basically a big warm group. And so we have this concept called fleet. If you've worked with like pods and deployments, very similar. Game server to fleet is pretty much the same as pod to deployment. It's basically saying, hey, I would like this many number of a particular game server. That's really it. And that's great, right? So we're specifying 2. It could be 200, it could be 2,000, it could be 20,000. We also have stuff for autoscaling. I'm not going to talk about that today, but that's a thing. Now, why is that super important? So dedicated game servers are kind of special. They're special because what I refer to them as is they have in-memory state, and that makes them fun. So what do I mean by that? So the way I like to look at them is when players aren't playing on a game server, it doesn't matter if you shut them down, right? Like a web server, it doesn't matter if you have 20 of them, you take one down, the request can go elsewhere else. It's kind of similar to that, right? But when you have players on a game server, you can't shut them down. You can't shut down the node they're on. You can't shut down any of it because if you interrupt a player's play, like in the play session, right? Like while they're in the middle of a game, they tend to get really angry and they post mean things on Reddit and it's just a bad experience for everybody. So you need to be very aware at all times for any game server, whether there are players on it or not, because then you know whether or not you can shut it down if you need to scale down and save some resources, which doesn't match how, say, web servers work, right? Web servers are stateless, so you can shut them down at any point in time as long as you have enough left to handle the load. But they're also not like databases, which you can't really shut down ever, or if you do, you want to do it in a very ordered way. With game servers, you might spin up 10, and then like you might get the 3rd and the 7th done first. They need to be shut down and maybe replaced, or the 1st and the 3rd. There's no particular order that they're going to come in. So they need a very special thing. So fleets are great. So we can spin up lots of them. We have them warm and ready to go and they're prepared. How do we basically say, hey, I want a game server and make sure that doesn't get shut down? So we created this kind of new thing. I'll be honest, we kind of deviated a little from how Kubernetes does stuff. Usually Kubernetes is very declarative, right? You tell it what it is. You're like, hey, I want you to create 3 dogs for me. And it goes, I now created 3 dogs. And you're like, those dogs, I would like them now to be 4, right? It's very declarative. We came up with more of an imperative thing, and we sort of shoehorned it in, but it's worked. So cool. So we have this concept of what we call a game server allocation. And basically what that does is it goes and looks at all the ready game servers that match a particular set. In this case, what we're looking at is just everyone that's part of a particular fleet, but we can get much more complicated with it if we want. So the Synotic fleet. And basically, I would like you to, it's basically saying, out of the ready set, I would like you to give me one of those out of the set. And then I want you to mark it as allocated. And that allocated state that we looked at there, that is the very special state that says, hey, that game server, that's got players on it. So don't delete it. Don't delete the node it's on. Don't touch any of them. Just definitely no. Just no. Don't even touch it. Because otherwise players get really mad. And we don't want that. So let's start to see that in action. Because this is where things I think get really, really interesting. So let's create a fleet. Where are we? Fleet. Sorry, what am I doing? kubectl. I can actually do an apply. It's fine. Apply-f examples synotic fleet.yaml. So I'll write the whole thing. So again, we can start to see what's happening here with our fleets. We want 2 to be here. We have 2 current. We have 0 ready. We can have a look at our game servers like we did before. Here we're going to see we have a couple up. Okay, now they're actually ready. That's great. And so we have 2 that are there. We can also treat this like we would say a deployment. So we can say kubectl scale fleet synotic. Replicas, let's maybe make it 10. Right? In the same way as you could with say a deployment, for example. Yes, please. Yes, I see that. I see you putting the comment in there. Thank you very much. Yes, if you have questions, definitely drop them please drop them into there. Especially if I'm making no sense at all, I definitely would like to know, because that's always good to explain things as they come up. Yeah, or especially if I've also just assumed knowledge you have, please don't hesitate to be like, hey, I don't know what that thing is. So please definitely ask. I would much rather explain it and have you know. So now, if I look at my game servers, right, I have lots of them now, which is awesome. I have like 10. That's great. So let's do an allocation, and we'll have some fun. So this is probably something you'd probably do through the Kubernetes API. We actually have an externally facing allocation service you can use as well. But I can do this through here, which is kind of cool. Examples, Synotic, game server allocation, and I'm just going to spit out the results as YAML. So we're going to see it there. So what this is going to do is going to go through all the whole fleet, and basically it does some optimization type stuff for, we can get into that if people are interested, and picks one out for me to play on. So let's have a look. So let's hit that. I'm going to send the request into the cluster, and we get one back. So here, there's our game server, right? There's the address. We'll actually look at that in a minute. Gives us the name, gives us the port it's on, and moves the state to allocated. So now we have this game server in this particular state that says, hey, I have players on it. Well, since it's in that state, let's play a game on it. That sounds like fun. Let's do that. Let's go. And let me grab my mouse, pop back over here, so I can see the actual thing. All right, beautiful. So if I type this correctly, which hopefully I will, my dog is currently pottering around outside my door. I don't know if you can hear her tapping her feet. 7986. All right, click join. Wonderful. A black screen is good. I don't know why they do that. It's mainly to give me a heart attack, I'm fairly sure. But what this is going to do is connect to the this particular game server running on a Kubernetes cluster. It's running in US West 1 or something. Make that direct connection we were talking about previously. And now I can play a game of Synotic. Now I'm currently playing against 4 bots that are running on the server. let me see if I can find some. This inevitably always happens where I try and demo this game and I literally cannot find any of the other players who are in the game with me. Oh, there you go. Haha, wonderful. And so you can see, like, I'm just playing this like I would normally. It's doing that direct connection we were talking about previously. And I'm killing. I'm actually doing well today. And it's all going pretty well. So you can see it's all kind of working, right? Like you can see that access all happening there. All right, let's shut that down. Okay, so we can see a game played. That's awesome. But I want to show you this is like why this is sort of really important. So let's look at our game servers. We can see like some are allocated there. Let's run that again. Let's just actually allocate like 2 or 3. Let's give me 3 of them, for example. And we'll actually have a look at that very special state we were talking about previously. Actually, no, let me backtrack that for a sec, actually, before we do that. I'm going to show you one other thing. So one of the other things that's also nice, because we're bundling all this stuff together, if we pop over here, Agones also comes with a whole bunch of statistics and metrics that come with it. So this is just one of several dashboards. Here we can start to see like how many game servers we have, count by type, how fast they grow and shrink, right? All these kind of just useful stuff that you need. This is what's kind of one of the other nice things about bundling this all together. You can kind of throw all this stuff together. That's all just useful specifically. Like specifically, we're doing this for games. So we can kind of bundle all together. This is using Prometheus and Grafana. And it's all open source and it works out pretty well, which is kind of nice. So we can do this kind of fun stuff too. How are we doing for time? We're good. Beautiful. Okay. So we did a scale before, right? Fleet Synodic. But we were talking about if players are playing the game like we were just then, we saw we had several allocated. We don't want to interrupt that. So what happens if I scale that fleet down? Now, if I did this dual deployment, everything would go away. But on a game server, we don't want that to happen because players are playing the game, you have that in-memory state, and you don't want to interrupt them. So if we have a look at our game servers now, you can see the rest have all gone away, but those ones that are allocated, they do not die. They will not go away unless they're explicitly deleted individually or they self-select themselves, which usually is what happens. A game server will be like, hey, through the SDK, it's time for me to shut down. So we can start to build these very custom lifecycle tools into the system that work with Kubernetes as a whole, but just work that little bit differently so that they work specifically for our use case. And that's just hugely powerful. It's really impressive, the kind of stuff you can do with the extensions to Kubernetes. So to kind of like dig into that even more, now we can take this whole fleet of dedicated game servers and be able to pull out one individually when the matchmaker then wants to do the matchmaking. And that can then get passed back up to the Kubernetes API. Right, so we can start adding these layers of complexity and providing more stuff there too. Awesome. And like we've just kind of scratched the surface of Agones here, showing you sort of the basic functionality. There's lots and lots of more that we're working with. It's Kubernetes, so it works across all cloud providers, right? There's nothing magic in any of the stuff we do. There's nothing like, I work for Google Cloud, but there's nothing GKE specific in there. It's all pretty like, it's just standard Kubernetes stuff. We have fleet and node autoscaling. So we take advantage of the Kubernetes autoscaler. Again, I think you see a pattern here where we're just trying to like stand on the shoulders of giants and let people do a lot of this work for us. We saw some of the local development tools we're able to build some of that, which is really awesome. We saw some of the metrics and dashboards. We also have tools for ping latency. Like we were talking about previously, you know, certain games have certain latency requirements. So being able to measure that is really handy. So we built some tools for that as well. Basically, we just have all these wonderful toolkits for doing stuff with these game servers pretty much, which is super fun. And we're still working on it. Like it's still going on. We're doing we're doing a bunch of work around metric collection and display, like how to track in-game metrics and how we can expose them, as well as other metrics that may be specific to game servers that are useful. We're doing a lot of work around allocations at the moment, trying to do more sophisticated allocations. How do you like maybe even reallocate? Like I want to just give me the game server that's already been allocated. And there's some really interesting use cases for that. Windows hosting has always been a thing as well. There's still Windows workloads and a lot of them are gaming. So being able to use Windows container is something that I know nothing about, but we've definitely had some interest over the years, and it seems to have ramped up a little bit again, which is also super nice as well. Okay, so we'll wrap things up, and we'll make sure we have time for questions as well if people have them. So what do we do? So we took our dedicated game server, right, which is normally just like a bespoke process. We stuck it inside a container, which is always awesome because containers are awesome and you can use them all over the place. And then we made this extension layer that sits on top of Kubernetes, and that enabled us to scale and orchestrate lots and lots of these game servers. So then people can play these very large scale multiplayer games and use the power of Kubernetes to do it. And really just take advantage of all the stuff that Kubernetes gives you. And we can just put just an icing on top, which is just, it's just so much fun. It's so cool. Awesome. So yeah, before I'd love to get into questions, but if you want to learn more about the stuff that I work on or how all that stuff works, you can go to agones.dev, read our documentation, get stuck into our GitHub, see how all the code works and pick it apart. I have thoughts and feelings on if we rebuilt this all again, what would we do? And if that's different, if we want to go into that question, that's always a fun one too. You can follow us on Twitter at agonesdev. We do have a managed version of this, cloud.google.com/game servers. I will mention that as a small plug for us. That's all I'm going to do. Kubernetes as well. Obviously, that's a thing. And if you like the stuff that I do, you can follow me on Twitter at Neurotic. I occasionally stream open source on twitch.tv. I'd love to get back to that. I really should. It'd be great. But you can see a lot of my live streams up on YouTube, as well as I've done series that I also should get back to called Online Game Technology Drawn Badly, where I explain online game tech or stuff that how to power like dedicated game servers, peer-to-peer stuff, all kinds of other things like that, scaling databases for games as well, all through my very terrible drawing. It's fun, I think. All right. But finally, yeah, I'd love to get any questions, but thank you so much for spending time with me and listening to me. I hope you found that useful and interesting. So yeah, I really appreciate it. Thank you so much.
Thank you, Mark. Mark, it's a big pleasure. To be honest, so interesting, so funny.
Ooh, and I can't hear anything.
Maybe I have a couple of questions for you. The first one is about, for example, maybe one guy, if right now is thinking, okay, I want to create or make my own video game, but my budget is not so huge. So what do you can recommend to these people in order to, okay, maybe the budget is not $millions, but about what stack or what recommendation can you give to this kind of people?
Ooh, I think I heard most of that. I apologize. My my Bluetooth headset died. So while I was in the middle of that, and so I missed it. So what was I going to say? So basically the question was, just so I understand it, was if you don't have a lot of money and you want to get involved with this kind of stuff. So that is always a really interesting question because what's the word? If you have a hit video game, then you will end up having to put services around the world if you're running this kind of game. Now, ideally, you will want to, what's the word I'm looking for? Ideally, you will want to grow that as your player base grows, right? That kind of thing. What I'd probably recommend if you're looking to get into this kind of stuff, there's no real great look. Actually, no. I'll take a step back. If you're looking to get started, there are other what's the word I'm looking for? Proprietary services that do like game backends as services out there. Perfect. There's one that I work with who's a partner of ours at Google Cloud, so inherent bias, called Excel Bytes. They run on top of Agones and Google Cloud game servers. And they run a whole bunch of other game services as well. So like leaderboards, virtual goods, user like authentication, like all that kind of stuff. So if you're like, I don't want to do all this stuff myself, maybe all the control is not required for me, or I'm not worried about that too much. I just want to start with like a provider. That can actually be a really nice way to come in because they can give you, it's more opinionated and then more sort of prescribed in how you can do stuff, but you can sort of have more of a platform as a service type experience that you might be necessarily looking for in that kind of environment. Does that answer your question?
Yes, this makes sense. Maybe the last one, what do you think about GKE for this kind of of things. I know that you work on Google, so probably you need to say, yeah,
GKE is great.
What do you think? Being honest, what do you think in comparison to, for example, another providers? Do you think GKE is a good option for this kind of things?
So yes, I'm inherently biased. I work on Google Cloud, and I know GKE the best. I have not used other providers, so I'm a terrible person to answer this question. I will say we have people that run these workloads on GKE. So yes, that is a great platform to do it. And we also do the primary amount of our testing on GKE, I think, for obvious reasons. So yeah, I think GKE is a great Kubernetes platform. So that is probably my answer.
Yeah, amazing. So yeah, I think so. No question right now, but I receive a lot of WhatsApp messages, and I don't know why the guys sometimes prefer send a WhatsApp message and not publish the comments into the YouTube. But people from Mexico, people from Argentina, from Peru, Nicaragua, giving you thanks, giving you the.
My pleasure. Thank you so much.
So again, maybe if you can give us different social medias in order that the people can follow you, Twitter.
Yeah, it's on screen right now, but Twitter @Neurotic. If you have follow-up questions and you want to reach out, my DMs are open. So definitely please hit me up there. I'll hit them up again, youtube.com/Mark S. Mandel if you want to see any of my YouTube videos. If you want to subscribe to me on Twitch, it's Mark Mandel. So you can go to any of those social medias and they'll lead back to the other social medias. So they all go do a big loop. So yeah, when I very occasionally I'm like, oh, I actually have an hour to work on something, like I'm like, all right, cool, I'll do it on Twitch. I hop on there if I think I'm doing something interesting and sort of plug at it. And you can actually see, I talk about how I build stuff, like how do you build testing frameworks and stuff for like Kubernetes extensions, or we're adding an extra layer on top of stuff that happens, or where of the performance issues we've run into. So talk about all that kind of fun stuff too. Okay. Christian, thank you very much. I appreciate it. Thank you for coming by.
Yeah. Thank you so much, Mark. Again, a big pleasure having you here in the community. So I hope that maybe in the next year, why not, another opportunity that maybe you can again share your knowledge with us. Probably would be a great opportunity, a big one.
See if we can make that happen. If not, I'm sure I can recommend many of my wonderful peers who would love to come visit you as well.
Nice. Thank you so much, Mark. See you. Have a nice night.
You too. Bye-bye.
Bye-bye. Okay, guys. We'll switch to Spanish. Gracias, gente, por toda la oportunidad, por todo el chance de haberse conectado. Gracias de nuevo a Mark por esta gran oportunidad, por este gran chance. Para finalizar, voy a compartir. Vamos a hacer un pequeño sorteo. Vamos a compartir. Voy a compartir mi pantalla. Vamos a hacer un sorteo. Vamos a sortear 2 gift cards de Amazon. Aquí tenemos la lista de participantes hasta el momento que estuvieron participando y se inscribieron correctamente en la plataforma. Así que vamos a ver. Tenemos a Marco Prado Rodríguez y Juan Manuel Zúñiga Arias, son los ganadores. Tienen 10 minutos a partir de este momento para poder enviarme un correo a hellofalcon@gmail.com, indicándome que reciban el premio, y así verificamos de que están las personas en vivo viendo la actividad con Marco. Así que de nuevo, a Marco Prado y Juan Manuel Zúñiga Arias, 10 minutos a partir de este momento para que me envíen un correo confirmando su asistencia y confirmando también que vieron el premio como tal. Así que, gente, sin más, muchas gracias de nuevo. Espero que estén súper bien y que nos podamos encontrar en una